So let us start with the physics today. Okay, so the question says a physicist introduce a thin piece of glass, as you can see here, this is a thin piece of glass, into the path of a laser beam. So you have this laser beam in order to delay the beam, right? So if you put an obstacle in the path of light, what will happen? Its speed gets delayed. Are you getting my point? If you put any
Yeah.
obstacle in the path of the ray of light, its speed will gets reduced. Okay, so that's the delay will
Yeah.
happen. So the light of the laser beam has a single wavelength L in air. So the wavelength, do you know how we indicate the wavelength? That's the lambda, right? So lambda
Yeah.
in air, let's take it, is L according to the question. So I have indicated as lambda air is equals to L. While the beam is inside the glass, it completes 10 more complete oscillation. So if I see, to understand this, we can make our own diagram. See, so suppose we have a laser beam and it is propagating in air, it's no problem. And in the second case, we have a laser which is propagating, but I have substituted a glass here in the path of the, you can say,
Yeah.
laser. So
Yeah.
okay, and it is saying, see, it will do some oscillation in this glass width. So it takes 10 more more complete oscillations compared to the same beam passing through the air. So if I compare, for, see, I am comparing this same width. Suppose this is the width D. D is what? D is the width of your glass film or glass plate, anything, right? So this is still D. So
Yeah.
some number of waves will be present here also. So the question is saying,
Yeah.
in the case of glass, it has 10 more oscillations. Right now, I am doing nothing except explaining this question. I am explaining this question, So I think question is clear till now.
Yeah.
Okay. Okay.
Yeah.
The speed of the light in air is c. This is obvious. The speed of the light in air. So we can mention this information as well. So the speed of light in air is c, and the speed of light in glass. So speed in glass is equals to 2c by 3, which is less than c, as obvious. So now we have to find the thickness of the glass, that is the this d, right? And now when you see your option, then you will get that your d should be in terms of wavelength. Are you getting my point? I want my
Yeah.
thickness in
Yeah.
terms of wavelength, not exact value. See, I want my thickness of
Mm-hmm.
glass in terms of d, or sorry, in terms of lambda wavelength. Here my wavelength is L. Now I think question is clear. Now let us see how we can solve this, right? So what theory needed here? Okay, the first theory it requires is concept of refraction, concept related to refraction. Do you know what's the refraction is?
Yeah.
Nothing.
Yeah. It's when light change speed or direction when entering new medium.
Okay, very nice, very nice. So when a ray of light change its medium, then the bending of light happens, and this bending is called refraction, right? Now, do you know
Yeah.
that during refraction, or in the refraction, during, or we can say in refraction phenomenon, in refraction, which quantity change? I am giving option: velocity or the speed. The second one is frequency. The third one is wavelength. It may be your multiple choice question, right? More than one answer may be correct. I want to know, in case of
Yeah.
refraction, which quantity change and which quantity do not change. Do you know? Can you tell me which quantity gets changed?
Yeah.
Yeah, please tell.
Velocity and wavelengths change, but frequency stays the
Very
same.
good, very nice. So yes, this is going to change. This is still fixed, or you can say constant. Frequency never change, and this going to change. Okay, now see here. According to this diagram, we have a speed, and let us suppose whatever the frequency of this laser, I am indicated it by f. So if we apply, or we can, in place of f, you can also take it as nu, right? Do you know this nu is also standard symbol for frequency, right? So now I'm going
Yeah.
to apply my well-known equation, that is the v is equals to nu lambda. Do you know this?
Yeah.
Very good. So in the first case, in case of air, In case of air, what's my V? It's C according to question. The speed of light in air is C. What's the frequency? Let it be nu. And what's the wavelength? It is L, isn't it? It is given that
Oh,
its wavelength is L.
yeah,
Now, if I apply for the glass, what should be my velocity? It is given that it is 2c upon 3. So I should write here 2c upon 3. And what's the frequency? Still frequency is V or nu, sorry. And what's the wavelength? I assume it as L dash or L prime, isn't it? I have assumed that the
yeah,
new wavelength is L prime. So from these two equations, can we find the relation between L and L dash? Can we find the relation between L and L dash? So yes, we can find. Let us divide it. Let us divide it. Let us suppose this is the equation number 1. This is the equation number 2. I'm going to divide 1 with equation 2. So I will get C upon 2C upon 3 is equals to nu L upon nu times L dash. So see, nu and nu gets cancelled out. This C and C gets cancelled out. So you will get 3 upon 2 is equals to L upon L dash C. So what is the L dash here? So L dash is
yeah,
2 upon 3 L, isn't it? Right?
yeah,
See, right now I am discussing
yeah,
this question in full detail. Just after completion of this question, we will see how we can minimize this time, how we can minimize the steps. Right now I am doing in a full detail. Is it okay? So now you got
yeah,
that what's the relation between wavelength, or you can say L and L dash. Now let's go to our this. Now I want to find number of oscillations or number of waves in distance d. Now I want to find number of waves in this distance d. So in case of air,
yeah,
what it should be? See, what is the total length? D. And what is the wavelength in air? It's L. So this should be your number of waves in distance d. Are you getting my point? Why I have written this? Have you explanation?
yeah,
Yeah. Is it okay? Sure.
yeah,
Okay, so now I'm going to write number of waves in glass. So still the distance is d, but my wavelength is L dash, L prime, isn't it? So this will be the number of waves
yeah,
in distance d in case of glass. The question is saying that it has 10 more oscillations. According to question, the glass has more oscillation. What does it mean? It means if I add, it means in air it has less oscillation. So in air this is the number of oscillations. If I add 10, I will get this d upon L dash, isn't it? What do you say? Is it okay? So now
yeah.
here uh,
Mm-hmm.
we have the L dash in terms of L. So I should write d upon L plus 10 is equals to d upon, and L dash is what? L dash is, see, 2L upon 3. So L dash is 2L upon 3. So this 3 will go upside. So you will have d upon L plus 10 is equals to 3d upon 12, isn't it?
Yeah,
So I am shifting this to other
yeah,
side. So this 10 is equals to 3d upon twice of L minus d upon L. I should make it a like fraction. So doing this, so I am getting 10 is equals to 3d minus 2d, that is the d upon twice of L. So from here we can get d is equals to 20L. It means 20 times of wavelength in air. Let us check the option. Is there any option
yeah,
for 20L? Yeah, you may check it also. I think it should be correct. See, I have given so much explanation. There is no chance of error here, right? Now I want
mm-hmm.
to
Yeah,
reduce the steps here. Now I want to reduce the steps here. See, you can reduce these steps. You can reduce these steps very easily. First, if you are writing anything, just write it and let me know that when we can proceed.
yeah. We can proceed.
Okay, see, we can, Harish, we can eliminate or we can short these steps. You know why? We have V is equals to nu lambda, right? And you know that in both the situations, in which it means in case of air and in case of glass, your frequency going to be constant. Your frequency is not going to change. Frequency is always constant. So what's the relation between V and lambda? What's the relation between V and lambda? It's directly proportional to lambda, isn't it?
Yeah,
So whatever the relation between the V, the same relation you will get in lambda. Since since in the case of glass, your speed becomes 2c upon 3, isn't it? So in case of lambda, it
yeah,
also becomes 2l upon 3 directly. You can see here. Are you getting this observation? See, my velocity is directly proportional to lambda. What does it mean? It means whatever happening with the speed, the same thing going to happen with the lambda. So it is given that the speed gets 2c upon 3. It's obvious that now its wavelength becomes 2l upon 3. Is it okay? So these all steps you can
Yeah.
eliminate
Okay.
directly without any calculation, just thinking. And after that you have to need only these, and these are the very simple equation I have put it here. These are the just steps I am writing step by step. So overall you can say this question can be solved in 2 or 3 minutes very easily if you have the logic.
Okay.
Any doubt in this explanation?
The 2L upon 3, where do you go next?
Oh, this after this one, after this.
Yeah.
See, so it means you have the relation. Now you have L dash is equals to 2L upon 3. Without any calculation, you can write this,
Yeah.
right? After that, you have to come here
Okay.
directly.
Okay.
After that, you have to come here directly. You have the relation between the number of waves in
Yeah.
distance d. We have a relation between the number of waves in distance d. So first, I find. Do you know how I have finded this d upon L? It should be clear, right? So I found a number of
Yeah. Yeah.
waves in distance d in case of air. I found number of waves in distance d in glass, and whatever the relation given according to question, I have just implemented that. I got my answer. That's all. So I'm saying
Okay.
that you can eliminate that calculation part. You can directly come to this part, and this is necessary part. Yeah, any other doubt in this question?
No.
Very good, very nice.